Well, in this problem, number 54, we have an individual that purchased a 4-year $10,000 promissory note with an interest rate of 8.5% per year compounded semi-annually. How much did the note cost? Okay, a promissory note is just kind of like when we were looking at that college problem where I was talking about how you wanted $40,000 available at the end of so many years. That's what a promissory note is. It's basically saying I need to make sure I've got $10,000 available at the end of 4 years. So how much do I need to set aside today for that to happen? Okay, and obviously it says compound semi-annually, so I'm going to use the compound interest formula. And we just need to plug in all the information. So I need $10,000 in the future. What I need to find is how much I need to put away right now. Okay, so I need P, I have A. It can be 1 plus the rate, so 8.5% is 0.085. The number of compounds, well, semi-annually means 2 times each year. Up there in the exponent then will be 2 times each year for 4 years. Okay, so just to solve this out, we just have to divide by this, what all this is over here connected to P. I'm going to write that as 8. Okay, so let's put each of these, let's put these in a calculator, and when we do that, we should get a p-value equal to, it looks like $7,167.89. So if I put that away, then right now, then for sure I have $10,000 available after 4 years. Okay? Okay, so number 57. We are looking at comparing two rates. In the last 5 years, this Bindex mutual fund grew at a rate of 10.4% per year compounded quarterly. Over the same period, Acme Mutual Fund grew at the rate of 10.6% per year compounded semi-annually. Which mutual fund has a better rate of return? Okay, so we have this, let's say, the Bindex Mutual Fund, which is, let's see, 10.4%. And we're going to do this compounded quarterly. So I'll say M is equal to 4. And then we've got another one, another type, Acme Mutual Fund. So we'll say Acme Mutual Fund. Okay, their rate is 10.6%, and it's compounded semi-annually. So M is equal to 2. So what we want to do is be able to compare these rates. And anytime we compare a rate, we use our effective formula. So let's find the effective rate for this Bindex Mutual Fund, and that formula is just that, 1 plus our rate, so 0.104, divided by the number of compounds, which is 4, to the 4 minus 1. Okay, so the effective rate for this mutual fund comes out to be 0.10812, or we're going to say that's basically 10.81%. Okay, so that's its comparison. Let's do the same thing over here with Acme. So the effective rate then for Acme is 1 plus 0.106 divided by 2, because we're compounded semi-annually, to the 2 minus 1. Okay, so when we use this in our calculators, we're going to get an effective rate of 0.1088, or 10.88%. So the question asks us, back to looking at number 57, which mutual fund has a better rate of return? Well, what this is doing by looking at the effective rates, we've now gotten common rates, and it looks like since 10.88 is higher than 10.81, then we definitely want to go with Acme Mutual Fund for this case. All right, and again, always use this effective rate formula whenever you want to compare rates. Okay, let's go on the next problem. Well, before I start writing some stuff down on here to kind of talk about notes on number 68, let me just kind of read through it with you guys just for a second. It says Maria, who's now 50, okay, she's employed by a company that's guarantees her a pension of $40,000 when she gets to be 65. So, in other words, 15 years from now, she's going to be guaranteed $40,000. We want to know what's the present value of her first year's pension. So what's the present value of that $40,000 if the inflation rate over the next 15 years is 6% compounded continuously, or 8% compounded continuously, or 12% compounded continuously? Okay, so in each case we have a t-value of 15 years. Okay, we have several different rates, but we know we eventually want an accumulated amount of $40,000. What we're looking to find are our p's. So one time, every single time we're going to be compounding continuously, so we're going to use the PERT formula, PE to the RT. Okay, so we know T is 15, we know A, it's 40,000. P is what we're finding every single time, and what A is changing. One time it's going to be 6%, the next time they said 8%, and the last time it's going to be 12%. Okay, so let's solve this one out. Here's for the 6% one. Okay, so we know we're going to have $40,000 paid to us. Okay, and I don't need the parentheses really, so we're just going to use our PERT formula. So P is what we're going to find. E, the rate this time is going to be 0.06 times 15. Okay, so in this case, since I'm solving for P, e to that power is just an actual number, so I can really divide it off. So I need to take $40,000 and divide it by e to that power to figure out how much that company needs to set aside right now in order to be able to give me $40,000. Okay, so P is going to equal, looks like $16,262.79 by the time we round. Okay, so over 15 years for that company, if they put away $16,000 right now, that's why companies always need to be saving money, because definitely to their benefit, right? Because $16,000 is going to grow to $40,000. Way easier for them to save $16,000 than for them to cut a check right away at 40 at the very beginning. Okay. If we do the same thing for 8%, let me just kind of skip to this part. You basically take your $40,000 and we're going to divide it by E. All we have to do is change that rate. So it's going to be 0.08 times 15 is going to equal P. Okay, so let's do this one more time. And with the 8%, then we're going to get a P value of $12,000, $12,047.77. Okay, so that's at the 8% rate. And then to wrap this up just one more time at the 12% rate. By the way, look how much easier it is for them by just going from 6 to 8%. They have to put what, $4,000 less away? Not too bad. Okay. And then if we wrap it up at the 12%, let me just go and get an answer. This is going to be the same thing. You're basically going to do $40,000, and then it's going to be E raised to, then this time it's going to be the 0.12 times 15. Okay, and so when I do that one right there, I get a P value. So I'm running out of room here. Look how much, this is so crazy. $6,611.96. My goodness. Do you see, guys, how it's all about your interest rate? So when you go to your bank and they say, hey, we're going to compound your money monthly, you'd be like, I don't care. I want the interest rate. And trust me, do that every single time. Start watching commercials. They're going to start talking about interest or the number of compounds. And I want you guys to realize it has nothing really to do about compounds. It's all about that interest rate. Even if you can get another 0.5%, it's way worth your time.